Chapter 5, Section 1, we're going to go over how to locate any relative extrema or inflection points for our natural log function. So, example 17 here, we have y equals x squared times the natural log of x over 4. This one's very similar to one of your homework problems, so I want to make sure that I kind of helped you guys go through this one. So, the first part of our solution is here, we need to rewrite that log with the division as subtraction. So when we rewrite that, we're going to get x squared times natural log of x minus natural log of 4. Let's go ahead and distribute that x squared through. So you're going to have x squared natural log of x minus x squared natural log of 4. There are other ways to do this problem. It's still going to end up being a product rule just in general when we do this. But for simplicity's sake, I say we're going to go this route where we distribute the x squared through. So I'm going to call a left-hand term and a right-hand term. The left-hand term is going to be the x squared natural log of x, and the right-hand term is going to be minus x squared natural log of 4. So when I say left and right-hand term, that's really what I'm going to be referencing in this problem. So if we take the derivative of the left-hand term, it's a product rule. So first times the derivative of the second plus second times the derivative of the first. So we take first term, which is x squared, times the derivative of natural log of x, which is 1 over x, plus natural log of x times the derivative of x squared, which is 2x. So we've done the left-hand side. The right-hand side, still a product rule. First times the derivative of the second. Well, natural log of 4 is just a constant, so the derivative constant is 0, so that term is going to go away. Plus the second term, natural log of 4 times the derivative of the first, which is 2x. Okay, the next thing you got to make sure is that that minus sign, that subtraction, distributes to that negative, to the 2x natural log of 4. So that's why it becomes minus there. Alright, we have x squared over x in front here, plus 2x natural log of x minus 2x natural log of 4. So the x squared over x reduces to x, and then we have 2x ln x, natural log x, minus 2x natural log 4. So for us to find the critical numbers, okay, we have to set the derivative equal to 0. So that's the derivative, what I just read off. We're going to set it equal to 0. So the first thing I would do is factor out an x. Okay, that's going to make it easier for you to solve. Factor out an x and then divide both sides by x. Well, 0 divided by x is x. So that x that we factored out gets to go away, or you can say that it's equal to 0 if you want to do it that way as well. But we can divide it out. So we're really left with 1 plus 2 natural log of x minus 2 natural log of 4 that we have to solve. Okay, so we can break this down. 1 is a number, 2 natural log of 4 is a number. Okay, or we can do things a little bit differently here. And I'm going to show you a more challenging way, I think, on this one than you're used to. It's okay. We're going to cover this in a later section as well. So if you can just follow the steps or use your calculator to get the value on your homework assignment, but this one's going to be a little bit different. You haven't had to solve a log before, but we're going to go through and do it this way, just so you get a taste of it, because you are going to do it in this section, or in this chapter anyways. Okay, so we're going to have negative 2 here. I'm going to factor out this, we have negative 1 equals, I'm going to factor out the 2 and be left with natural log of x minus natural log of 4. I could have factored out a negative 2, I could have done there's a bunch of different avenues to do this problem. So whatever your forte is, that's fine. So we end up with negative 1/2 because we divide both sides by 2 equals natural log of x minus natural log of 4. I did that so I could rewrite this natural log of x minus natural log of 4 using the log property as a simple division now. When I do that, there's a rule in inverse property that we're going to discover soon where I can say set e as a base because e is the base for natural log, so I can exponentiate both sides with a base of e. So I'm going to get e to the 1/2 on the left hand side, e to the natural log of x over 4 on the right hand side. The e and the natural log actually cancel with each other, okay, based on inverse properties we're going to cover soon. So what will happen when we solve this, e to the minus 1/2 equals x over 4. Just solve this for x, so we're going to multiply both sides by 4. So that's our critical number, x equals 4e to the minus 1/2. Now, we're going to take that, because that's just the x value, we're going to take that and substitute it into the original equation to get the y value. Okay, so the original equation is up here, the x squared natural log of x divided by 4. So we're going to substitute that in over here. I'm going to rewrite that in a little bit differently. I've taken that x equals 4e to the minus 1/2, and I wrote it as 4 over the square root of e. So I'm going to rewrite that first because that's going to help us simplify when we break things down here. So when we plug it in for the x squared, we're going to get 4 over square root of e quantity squared. That's replacing the x squared. And then we have natural log of 4 divided by square root of e over 4. Okay, that's replacing the x in the x over 4 portion there. So on the left part of this, 4 squared is 16. Square root of e squared is e. Times natural log. Well, this is really 4 over square root of e divided by 4. So I'm going to multiply by the 1/4 to the numerator and the denominator. So those fourths technically cancel out based on rules of fractions and things like that. So we end up with a natural log of 1 over the square root of e. And then we just keep simplifying. I rewrite natural log of 1 over square root of e times the natural log of 1 minus natural log of square root of e using the log properties of division. So we have 16 over e in front multiplied by natural log of 1 minus natural log of square root of e. Okay, natural log of 1 is 0, so that term is going to go away. And then we have natural log of e to the 1/2. You're going to be able to put that in your calculator, and we're actually going to get a numerical value here. We can bring that and rewrite that power down too, so that'll give you negative 1/2 natural log of e. Okay, natural log of e is 1, so it's really just 16 over e times negative 1/2. We end up getting negative 8 over e, which we can rewrite as negative 8e to the minus 1. So our solution for where the relative minimum is 4e to the negative 1/2, comma, negative 8e to the negative 1. So that's where our relative min is. So that's taking the first derivative, setting it equal to 0. Now we want to find points of inflection, alright, concavity, and those sort of things. So now we're going to find the second derivative. So we're going to take that first derivative, which was x plus 2x natural log of x minus 2x natural log of 4. So we're going to take the derivative of that and set it equal to 0. So that's not too bad of a derivative. It looks like it could be, but it's not. Alright, so the derivative of x is 1 plus the derivative of 2x natural log of x. That's a product rule, so we got to go first times the derivative of the second. So it's 2x times the derivative of natural log of x, which was 1 over x, plus the second term, which is natural log of x, times the derivative of 2x, which is 2. Okay, that's the middle term we just took care of. Minus, same thing on the outside here, product rule, we have 2x times natural log of 4, but natural log of 4 is a constant, so it's going to be first times the derivative of the second, so 2x times 0, the derivative of natural log of 4 is 0, plus natural log of 4 times the derivative of the first term, which is just 2. Making sure that we're keeping track of that subtraction sign that has to distribute. So when we do some algebra and some simplification, we're left with y double prime, or the second derivative, is 1 plus 2 natural log of x minus 2 natural log of 4. Okay, and then we're going to simplify that down by factoring out a 2 out of the natural log function there. So when we do that, that helps save some things when we actually have to solve this and move forward. Okay, so we're going to set that equal to 0. Okay, we're going to move the 3 over. We're going to divide by 2, so we're going to get negative 3/2, and that's going to equal the natural log of x minus the natural log of 4. Now we're going to exponentiate again when we do that. So we can use e again. So we're going to say e to the negative 3/2 equals e to the natural log of x divided by 4. And once again, we can do that using the inverse properties. You should have learned something like that in Algebra 2, but if not, we're going to cover it again a little later in this chapter. So you will know how to do that very soon if you don't follow it in this one. But always use e with natural log because e is the base of natural log. So when we do that, okay, e and natural log cancel out, so I'm left with e to the negative 3/2 equals x divided by 4. I'm going to multiply both sides by 4 and get x equals 4e to the minus 3/2. That's our x value. We've got to find the y value. So when we do that, we have to take that x equals 4e to the 3/2, substitute it into the original equation. Once again, rewrite that x with square root function, so it's going to be 4 over the square root of e cubed. Remember, the numerator goes with the variable, the denominator is the root when we rewrite those. So the original equation was x squared natural log of x over 4, so we're going to substitute into that. When we do, on the left part of it, we're going to get 4 over square root of e cubed, and when we square that, we're going to get 16 over e cubed. And then once again, when we take natural log, we're going to have 4 divided by the square root of e cubed divided by 4. Those 4's are going to cancel, so we're left with the natural log of 1 over the square root of e cubed. Then we're going to use the division property to expand that out. So we're going to have 16 divided by e cubed. And remember, when we expand this out, that 16 over e cubed is going to have to distribute to each term. So we're going to rewrite that as natural log of 1 minus natural log of the square root of e cubed. Now, natural log of 1 is 0, so that term is going to go away. Then we're going to have natural log of, let's take that radical, or that square root sign, and rewrite it as a fraction. Natural log of e to the 3/2. Then we can use the power rule, that 3/2 can come down in front. So we're going to have 16 over e cubed times negative 3/2 natural log of e. And we know that the natural log of e is 1, so I can replace that. So it's really 16 divided by e cubed times negative 3/2 ends up giving us negative 24 over e cubed. And if we write that out, it's going to be negative 24 e to the minus 3. So the solution where our point of inflection is, is going to be 4 e to the minus 3/2. We found that by setting the second derivative equal to 0. That was our x value. And then we took that x value and put it into the original equation to get the y value, which is negative 24 e to the minus 3. Okay, so there's a step-by-step process. So let's take a look at the graph now of that function. If we take a look at the graph, we can see that that's where the relative min is. So that's where we set the first derivative equal to 0 and solved. Okay, and then we can find the point of inflection. Remember, that's where we're changing from concave up or concave down, okay, by setting the second derivative equal to 0, and that's where that occurs there. So we can take a look at it graphically as well and go on about that. So fairly lengthy example. You have 1 or 2 homework problems, one very similar to this and one much easier than this. So the next video will wrap up section 5.1. We'll just talk about being able to take an expanded log function and condense it into a single quantity.